Hello, everyone, and welcome to this press briefing for the Global Climate Highlights 2025. It's a pleasure to have you all here. I'm Jeremy Wilks. I'm your host today, and I've been covering climate change issues since 2019. In the next hour or so, we'll hear our panelists discussing the 2025 Annual Climate and Atmosphere Summary based on data from the Copernicus Climate Change and Copernicus Atmosphere Monitoring Services, both implemented by ECMWF on behalf of the European Commission, as well as data and scientific information from ECMWF. We'll be sharing with you the latest graphics and data, and of course, we have that all-important question and answer session coming up very soon. Before we start, let's quickly go through our housekeeping rules for today. Firstly, please respect the embargo. A lot of work has gone into this, and we'd like you to respect that scientific endeavor by programming all of your articles, videos, and social media posts for release from 0400 hours Central European Time on Wednesday, the 14th of January. Whether you're working for broadcast media or written press, local, national, or international news, everything you need should be in the online press kit. Please follow the link to download whatever you need. And in case of questions, please contact the Copernicus media team at ECMWF. This Zoom media briefing will be recorded and also available on the press resources page after we lift the embargo. We will have the press release translated into 10 languages, and the video material, the B-roll, will be available in English. Let me now bring in Florian Pappenberger, the new Director General of ECMWF since the 1st of January this year. Florian, great to see you. What's your big takeaway from this year's Global Climate Highlights?
Thanks, Jeremy. I think the biggest takeaway that the 2025 is the third warmest year on record, just after 24 and 23. And well, that's not particularly good news, because we sort of, for the first time, we've exceeded the 1.5 degree limit in 3 years. And the last 11 years have been the warmest on record. It's our data showed us dramatic change in climate change, but it's not just our data, it's also the data of our peer institutions. And the Copernicus Climate Change Service and Atmospheric Service that we've implemented on the European Commission have really important to show this really dramatic shift of the climate in Europe. And I hope that our services, and I know that our services and our data inform meteorologists, scientists, and particular decision makers to help to react to this climate change and take decisions on that.
You're pretty new in the job, just started actually. Can you tell us a bit about the work, the collaboration that you're doing within and around ECMWF to arrive at the point where you can publish this global climate report?
Indeed, I've just started a few days ago. Collaboration at ECMWF is really core. It's really at the center of what ECMWF does. It's our DNA. We've done this now for 50 years. And this climate change report, or this global climate highlight, is only possible because of our close collaboration with our member states and their meteorological services, with scientists all across Europe and beyond Europe, across disciplines. And really, hundreds of people have worked together in trying to get this basic reanalysis data set, which sort of stands behind that, together in order to show you what you've seen today. We operate, of course, also the medium range forecasting. So we produce a medium range global forecast, and the techniques and technology which has been used to produce this forecast, this world leading forecast, is also the same which stands behind this reanalysis data sets. So collaboration is really key, and I think you couldn't do it with all these different knowledges and scientists and different disciplines to produce this amazing report of wealth of information. And really to sort of come together and make sure that science delivers the best knowledge and best data source for decision making.
Absolutely. Well, we'll be coming back to you for the question and answer session. Thanks very much for that introduction, Florian. Let me pass over now to Mauro Facchini, who's the head of the Copernicus unit within the European Commission's Directorate General for Defence, Industry and Space. Welcome, Mauro. Nice to see you.
Yes, my pleasure, Jeremy. So, dear representatives of the media, ECMWF colleagues and guests, good afternoon to all of you, and my best wishes for 2026. So the release of the annual Global Climate Highlights is now a much expected event. It's a tradition practically in the new year. and it is with immense pleasure that we welcome this new edition of the 2025 Global Climate Highlights issued by the Copernicus Climate Change Service. As mentioned by Florian before, exceeding a 3-year average of 1.5 degrees above pre-industrial levels is a milestone that none of us wished really to see. It reinforces the importance of Europe's leadership in climate monitoring to inform both about mitigation and adaptation. The news is not encouraging, and the urgency of climate action has never been more important. By monitoring how our climate is changing and the risk that these changes will bring, we can plan for a more climate resilient future. Copernicus was created exactly for that reasons, to provide policymakers, businesses, practitioners, scientists, and citizens in Europe and across the world with trusted independent insights to inform decisions. Today's results that we'll see later show just how vital that mission has become. Thanks to the Copernicus free and open data access policy, anyone can make use of the Copernicus satellite and in situ observations, models, and other added value products about past, present, and future climate and transform them into useful knowledge. Copernicus offers unique capacities and tools to monitor our climate, to underpin EU's climate change mitigation and adaptation strategies, to track our progress on the Paris Agreement, and to accelerate our green transition.
Thank you, Mauro. I'm just thinking about the next 12 months. What have we got coming up this year from Copernicus, and what have we got on the horizon looking forward?
Yes, so from the program point of view, I think in the last year we've seen the launch of 4 satellites. This for us was quite important. I think in past years, due also to some issues with launcher and so on, we had to stop a little bit. But 4 launches last year, and in particular 2 satellites, so Sentinel-4 and Sentinel-5, that will support the monitoring and greenhouse gases and the observation of other pollutants. This is quite important what we are discussing today. And now, even if it looks quite far, we are already working to the next financial cycle, so the so-called EU multi-annual financial framework that will cover 2028 to 2034, including both operations and research activities. Indeed, this new budget will encompass the launch of new satellites, but at the same time, how to better integrate the data coming from these satellites in actionable products, and in particular, what has been done up to now with C3S and CAMS. Among the satellites that we plan to launch is really the continuation of the existing ones, but also new satellites that we call expansion missions. And among those, particular attention is with the CO2 mission, with expect launch of 3 satellites. Let's say by 2030, all the 3 should be launched. And this will support observation of anthropogenic emission for greenhouse gases. In that respect, we still plan that Copernicus will play an important role in implementing tailored new tools and platforms for European climate resilience and risk management. And in the current global context, this is proving essential as some start again questioning climate change and the role of evidence-based decision-making. The EU remains committed to the green and digital transition. Artificial intelligence is expected to play a growing role. We know ECMWF is also looking a lot on these new digital technologies. And ECMWF, who is implementing the Copernicus Climate Change and the Atmosphere Monitoring Service, is fostering world-class innovation in this direction. New priorities are emerging, including around competitiveness, resilience, security, defense, and business innovation. This is the reason why for the next business process, so in the period 2028-2034, we remain quite ambitious. For those that have the chance to see the European Competitiveness Fund, there are 130 billions that are more than that are proposed for defense and space, and a big chunk of that will go into space, and also in the continuation and evolution of Copernicus. In closing, let me thank ECMWF and C3S and all contributors for summarizing these crucial 2025 findings that we'll see just after this. Thank you very much.
Thank you very much, Mauro, and we'll be back to you for the question and answer session later on as well. Let's now bring in the directors of both the Copernicus services at ECMWF. Let me welcome Laurence, the director of the Copernicus Atmosphere Monitoring Service, and Carlo Buontempo, the director of the Copernicus Climate Change Service. A quick question for Carlo to start. Your global climate highlights are all about presenting the best quality data for decision makers, as was already mentioned earlier. Can you give us an example from 2025 that shows how climate data was actually used to make a real difference to people's lives here in Europe?
Thank you, Jeremy. It's with great pleasure. And it's a pleasure to be on air with you once more. A good example for 2025 comes from the exceptional heat and fire across Southern Europe during summer. Thanks to C3S climate monitoring, we were able to show early that these conditions were historically unprecedented in terms both of heat persistence, soil moisture deficit, and human heat stress. Based on ERA5, the reanalysis that Florian was talking about, and the near real-time observation, this provided trusted shared reference for decision makers across Europe. This information could then be used in many practical ways. Meteorological services, civil protection, and health authorities could combine C3S indicators with local data to activate heat health action plans, adapt working time regulation, and prepare hospital, particularly for vulnerable groups. Tools such as the thermal trace that we published in the summer translated climate data into local specific heat stress information, supporting targeted local responses, while water and energy operator could use the same signal to manage reservoir, anticipate stress on hydropower and cooling system, and reduce cascading risk. What matters the most is that everyone could work from the same authoritative climate signal. By providing clear, timely, and comparable climate intelligence, C3S enables earlier action, better coordination, and real benefit for people's lives.
Thank you, Carlo. We've got a ton of great questions coming in from the journalists, and we'll get to those very soon. Let me go over to Laurence now. 2025, when we look back at that, it's not only those heat waves that Carlo was talking about, but also the wildfires in Europe that the Copernicus Atmosphere Monitoring Service was following very closely. Can you explain how the CAMS data helped the regions and the countries that were affected by those fires?
Thank you very much, Jeremy, and good afternoon, everyone. In fact, just in a nutshell, CAMS has two main activities on wildfires that could help better inform policymakers, but also citizens, especially in those regions affected by the wildfires. First, CAMS detects and monitor wildfires thanks to satellite observations, Earth observations, and can inform about the evolution and forecast also the evolution of those wildfires using a parameter that we call the fire radiative power. And this is the first aspect of our service. Second, crossing this information that I've just described, so what relates to Wi-Fi, fire radiative power, to land cover maps, high resolution land cover maps that could be also delivered by other Copernicus services. CAMS allows to assess the pollutants and the greenhouse gases that are released by the wildfires. So we are talking about, of course, CO2, carbon emissions, but also nitrogen oxides, particulate matter, black carbon that are air pollutants that have harmful impacts on health and environment. So this information that we deliver, Wi-Fi location, Wi-Fi evolution, and impacts on air quality is of course crucial for policymakers, to inform policymakers and citizens to take the good decisions.
Absolutely, yes. And another question for Carlo. We're in a period, at least where I live in France, where it has been what feels like unusually cold, perhaps not according to climatological records, but it feels like it has been rather chilly. We've had that in other parts of Northern Europe. We've had people kind of questioning or even starting to deny global warming online in various social media posts and things. How are you addressing those kinds of comments and questions now?
Yeah, well, you're absolutely right. I could not bike to the office this morning here in Bonn because of the black ice, and everything is still very, very white around our premises. I guess it's all a question of zoom, right? If you go very local and look only at a very specific moment in time, you can see all sorts of anomaly. But if you zoom out and look at the big picture, then the signal is extremely clear. So if, for instance, you were talking about France, I was talking about Germany. My wife is from Spain, near Barcelona, and the mountains around there were covered in snow just last week. That's unusual, not unprecedented, but quite unusual. But if you, from that specific moment in time, in that specific location, you zoom out and look at the year as a whole, then you realize that the same region experienced one of the warmest years on record. And it's just a matter of framing the issue properly. So if we scale to the planet scale, as you will hear in a few minutes from Samantha, you realize that this last year has indeed been one of the warmest we have ever lived.
And Laurence, you're following emissions very closely. A kind of a question that we journalists are asked quite often, I suppose. What would happen, kind of what if questions, what would happen if emissions from human activities stopped rising tomorrow? Would we still carry on seeing these warm years like 2025? And how are you monitoring those kinds of greenhouse gas emissions at the moment at CAMS?
So, you know, in fact, greenhouse gases are characterized by their long lifetime in the atmosphere. And when we are talking about CO2, we are talking about centuries. So as long as we keep emitting CO2 in the atmosphere, it accumulates in the atmosphere and it continues to destabilize the climate. So, of course, it's essential to close the tap. But we obviously know that the bathtub will continue to overflow. So what we could say is that certainly years like 2025, there will be other years like that in the future, even if we take action. But it shouldn't prevent us to take ambitious and urgent actions, of course. And this is what we monitor with CAMS, with our systems based on Earth observation, in situ observations, models to assess emissions, to assess the evolutions and the trends of greenhouse gases concentrations in the atmosphere, and also to see what are the impact of the mitigation strategies that are decided at the international and national level. So this is our best way to inform policymakers and citizens about the evolution.
Yeah, it's absolutely fascinating to look at that data and see what's really happening in the atmosphere, because the atmosphere doesn't lie. Thanks very much to Carlo and Laurence for that. So they will both be back to answer the questions which are coming in at the moment. Let me now welcome Samantha Burgess, the strategic lead for climate at ECMWF, who's going to run us through the key standout graphics from the Global Climate Highlights 2025. Sam, nice to see you. What's coming up?
Nice to see you as well, Jeremy. So Florian's already mentioned that 2025 was the third warmest year on record. So the presentation will be filled with statistics about 2025 and also some interesting data visualizations, which really showcase how our climate is changing and how it's impacting everyone around the world.
Okay, well, let's try and make that happen then. Show us the data, the graphs that the world needs to see.
All right, hopefully the presentation will load. We had some teething problems earlier today, but hopefully the webinar gods are on our side. Okay, if we can go to the next slide, please. There are some animations running and it looks like it's running, so that's fantastic. 2025 was another exceptional year for the planet. The ECMWF Era 5 dataset monitors the global climate back to 1940. Since that time, global temperatures have risen rapidly. The last 3 years, in particular, have been extremely warm compared to earlier years, and 2025 ended as the third warmest year on record. This means that the last 11 years have been the warmest 11 years on record. 2025 was only marginally cooler than 2023, while 2024 remains the warmest year on record, and the first year with an average temperature clearly exceeding 1.5 degrees above the pre-industrial. The average of 2023 to 2025 is 1.52 degrees Celsius, the first 3-year period to be in excess of that level. Here, the pre-industrial level is an average of global air temperature taken between 1850 and 1900 from multiple international data sets. This week, we will also see analysis for 2025 from other international groups, the UK Met Office, NOAA, NASA, and Berkeley Earth, who monitor the climate, and a synthesis from the World Meteorological Organization. The primary reason for these record temperatures is the accumulation of greenhouse gases in the atmosphere, dominated by the burning of fossil fuels. As greenhouse gases continue to accumulate in the atmosphere, temperatures continue to rise, including in the ocean, sea levels continue to rise, and glaciers, sea ice, and ice sheets continue to melt. I see that we're already on the second slide. If we could have it in full screen mode, please. And hopefully everyone in the webinar can see this as well. Many of you will have been here last year when we were discussing the record temperatures of 2024. Although 2025 as a whole did not break the record, January 2025 was the warmest January on record, and every calendar month has had its warmest month on record sometime during the last 3 years. These 3 years stand apart from those that came before. In 2025, the global monthly average temperature exceeded 1.5 degrees above the pre-industrial level during 6 months of the year, from January to April, and again in October and November. I would like to note that for this graphic, and for most of what follows, we use the 1991 to 2020 period as our reference baseline rather than pre-industrial. This enables us to look in greater spatial detail at the recent changes. If we could go on to slide 4, please. And we have another animation which will hopefully work. This animation shows a map of temperature anomalies, which means temperature relative to the 91 to 2020 baseline each year from 2001 to 2025. Blues are colder than average, reds are warmer. In 2025, annual surface air temperatures were above the average across 91% of the globe, the same fraction as in 2024. It is clear that as time goes on, there are more warm red regions and fewer cool blue regions. But even in 2025, there are places which experience relatively cool years by chance. One cold area does not mean climate change is not real. The global context is what matters. Next slide, please. In contrast to 2024, we saw larger temperature anomalies in both polar regions. In particular, Antarctica had its warmest year on record. Temperature anomalies relative to the modern reference period, averaged over 5 latitudinal bands, provide further insight into long-term warming trends across the globe, as well as notable regional differences in 2025 compared with the 2 earlier warmest years, 23 and 24. All regions show a clear long-term warming trend, although variability is larger in the Antarctic region. In the tropics, the temperature anomaly in 2025 was lower than that of 23 and 24. This reflects the persistence of neutral ENSO conditions or periods of weak La Nina throughout 2025, in contrast to the strong El Nino event that influenced parts of 23 and 24. Less extreme temperatures in the tropical Atlantic and Indian Oceans also contributed. This regional breakdown of temperature anomalies shows that the lower anomaly in the tropics reduced the global average in 2025, while record or near record warmth in most other regions partly offset this effect, resulting in 2025 being only 0.01 degrees Celsius cooler than 2023 globally. Next slide, please. As we've already discussed, the years 23 to 25 stand out apart from all years before. This graphic shows the areas which experience warmer in light orange or cooler in light blue than average temperatures, with many regions also showing much warmer than average temperatures in darker orange. The darkest red colours are reserved for the warmest year on record for that location. 2024 highlights the tropical regions as experiencing their record warmest year, whereas for 2025, this occurred in smaller areas in Northern Europe, Far Eastern Europe, China, and in Antarctica. Nearly half of the planet, 48%, experienced much warmer than average annual temperatures in 2025, and much warmer than average is above the 90th percentile of the modern climatology. For Europe, 2025 was the third warmest year on record, with an average temperature of 10.41 degrees or 1.17 degrees Celsius above the average for 91 to 2020 reference period. This was only 0.3 degrees below the record of 2024, and only 0.02 degrees Celsius cooler than 2020, the second warmest year. Only 1 month of the year, March, was the warmest for Europe. Next slide, please. The annual sea surface temperature for 2025 was still over 20 degrees. It was at 20.73 degrees Celsius and 0.38 degrees above the 91 to 2020 average. It ranked as the third highest on record, 0.13 degrees Celsius below the record set in 2024 and 0.07 degrees Celsius below 23, the second highest year. This makes 25 the warmest La Nina year on record, both in terms of global air temperature and sea surface temperature. In the equatorial Pacific, sea surface temperatures were cooler than average earlier in the year, reflecting a short-lived weak La Nina event in December 24 and January 25. Neutral ENSO conditions prevailed from March to July, and then cooler than average SSTs developed again from August, leading to a return to weak La Nina conditions in October that persisted until the end of the year. In 2025, record high sea surface temperatures were mainly found in the western and northwestern Pacific, the Indian Ocean sector of the Southern Ocean, the northeastern North Atlantic and adjacent North, Norwegian and Barents Sea, as well as parts of the western Mediterranean. About 9% of the extrapolar oceans experienced record high annual sea surface temperatures, and SSTs were much warmer than average, over 42% of the extrapolar ocean. Next slide, please. In the last couple of minutes, I've talked a lot about ENSO variability and sea surface temperature, and these two time series are really useful to help us to understand how exceptional ocean temperatures have been over the last 3 years. So when we look at sea surface temperature averaged over the extrapolar oceans, extrapolar means from 60 south to 60 north, so the ice-free part of the ocean. They have remained historically high throughout 2025, despite the absence of El Niño conditions. This contrasts with 2023 and 2024, as I've already mentioned, where the strong El Niño event influenced SSTs for several months in the second half of 23, peaking in December 2023, with SSTs remaining high throughout 2024. Surface ocean temperatures are declining and have recently been below those observed during the last extreme El Niño event in 2015. However, future evolution of ocean temperatures will depend on what happens to El Niño over the coming years. And I'd like to mention to people listening to keep an eye out for the C3S seasonal forecast, which monitors the probability of future ENSO events monthly. Next slide, please. No global climate highlights would be complete without talking about sea ice. So sea ice extent at both poles remained lower than average for virtually the whole of 2025. In March, the Arctic reached its seasonal maximum, but this peak was the lowest on record. In September, the Arctic annual minimum was the 13th lowest. Around Antarctica, 2025 saw the 4th lowest sea ice minimum in February, and the annual maximum in September was the 3rd lowest in the satellite record. However, the standout feature for sea ice for 2025 was that in February, the combination of record low Arctic sea ice extent for the time of year and much below average Antarctic extent at its annual minimum resulted in the lowest global sea ice cover for any month since the beginning of satellite observations in the late 1970s. Next slide, please. Obviously, these long-term trends aren't how society experiences climate change. It's not through the trend in global temperatures, but through extreme weather events. And extreme events in 2025 had significant impacts on human health, ecosystems, and infrastructure. Among the most exceptional events included floods, extreme heat waves, droughts, and wildfires. The consequences of rising global temperatures is felt particularly during heat waves, which are made more intense and more likely by continued global warming. During 2025, there were numerous heat waves, often breaking national or local temperature records. Heat stress represents the impact of the environment on the human body, so going beyond temperature to also include aspects such as humidity, wind speed, solar and thermal radiation, and the response of the human body to these factors. We are seeing an increasing trend in the number of days with heat stress, and 2025 was no exception, with 50% of the globe experiencing more days than average with at least strong heat stress. In 2025, some regions, such as most of Australia, parts of Northern Africa and the Arabian Peninsula, saw more extreme heat stress days than average. Extreme heat stress is equivalent to a feels-like temperature of more than 46 degrees, at which point it is critical to take action to avoid health risk, such as heat stroke. And as Carlo mentioned earlier, we have a newly launched application called Thermal Trace, which allows anyone to monitor heat stress throughout the year. Next slide, please. Using ERA 5, we can monitor the climate day by day. This animation shows how, over the past 85 years, the climate has become warmer throughout the year, with a shift to warmer temperatures in every season. For 2025, like 2024, there were no days below the 91 to 2020 average for the time of year. Next slide, please. A UK Met Office forecast issued late in 2024 correctly indicated that it was likely that 25 would become the third or even second warmest year on record globally. The corresponding forecast for 2026 is for a fourth consecutive year with an average temperature more than 1.4 degrees above average for the pre-industrial period, with the temperature for 2026 likely falling below that of 24, but close to that of 2023 and 2025. The WMO Global Annual to Decadal Climate Update for 25 to 29, released in June last year, reported an 80% chance that at least one of these 5 years would replace 2024 as the warmest year on record, and an 86% chance that at least one of the years would, like 2024, be more than 1.5 degrees above the 1850 to 1900 average. It also identified a 70% chance that the 5-year average warming for 25 to 29 would be more than 1.5 degrees above the 1850 to 1900 or pre-industrial level. Next slide, please. So where are we now? To conclude, with respect to global temperature levels that all nations around the world agreed to in the UN Paris Agreement back in 2015. Overall, the globe has warmed by about 1.4 degrees Celsius above the pre-industrial level. And if warming continues at the same average rate experienced over the last 15 years, then we will reach 1.5 degree level by the end of this decade. Obviously, 1.5 degrees Celsius is not a cliff edge. However, we know that every fraction of a degree matters, particularly for worsening extreme weather events. This concludes the presentation, and I now welcome questions during the panel discussion. Thank you.
Thank you very much, Sam. That was absolutely fascinating to listen. I believe there was a bit of an issue with, excuse me, some of the graphics at the beginning were not necessarily visible, but just a reminder, everybody, of course, can download that presentation. They can look at all of that information online by going to the link that's in the chat. Shall we switch on over to questions from the journalists already? We'll bring through Carlo and Laurence so that they can take part in this Q&A. Actually, let's scroll back along my timeline next to me and go to the first question that I had coming in from Andras Tot, staff journalist at the Hungarian science news site Qubit, who has a question for Carlo. You said that we are inevitably in an overshoot scenario. For impacts, what matters more, the level or the duration of the overshoot? Carlo.
Excellent question. I guess the simple answer is both. In a sense, we do know that many of the impacts scale with the global mean temperature. So by exceeding far beyond 1.5, we are likely to see more significant impact. At the same time, the length of the overshoot is a matter of exposure. It means that we are exposed for longer to this higher level of risk, higher level of temperature. So I would say both of them matter. And in a sense, the important message for me to convey is the fact that with 1.5 degrees in the terms of the Paris Agreement around the corner, now we are effectively entering a phase where it will be about managing that overshoot. Basically inevitable that we'll pass that threshold, and it's up to us to decide how we want to deal with the enhanced and increased higher risk that we'll face as a consequence of this.
Thanks, Carlo. Let's move on to a question which from Andras, which I think is actually, you wrote to Sam, but I think it's kind of a Laurence question, which is you're asking, in the press release, it's mentioned that the reduced uptake of CO2 by natural sinks as a factor behind the exceptional warmth of 2023-2025. What's driving the reduced uptake, and are we seeing an emerging trend here, Laurence?
Yes, thanks for the question. In fact, these natural things, those natural things on Earth and in the ocean, are influenced by many factors. And what the academic community highlighted is that it's true that in 2024, El Niño influenced it and limited the capacity, the Earth's capacity to act as a sink. For 2025, this is still a bit early to say how it will evolve. Data are considered. And what we can say is that there is a huge variability from a year to another, because there are many factors. So there is El Niño, there are the dry and warm conditions, and it's very difficult to say that now we have a trend that is an emerging trend. So we'll monitor that evolution, not only camps. This is not only camps. This is not only CISRIAs. There is a whole community behind this, but difficult to say today that there is a trend. But this is very important parameter to monitor.
Thanks very much, Laurence. Let's move to a question from Sophie de Villers at La Libre Belgique. For Sam, I believe the press release stated that the 1.5 degrees C limit could be reached more than a decade earlier than anticipated when the Paris Agreement was signed. How would you explain that? Is global warming accelerating? Were the models incorrect? Watch out for your microphone. There you are.
Yeah, thanks, Jeremy. And thanks for the question, Sophie. So this prediction is based on assuming the current rate of warming continues at the same rate as when the prediction was issued. So in the interim, we have, since signing the Paris Agreement, this simple extrapolation gives the 1.5 degree level about 10 years later if we extrapolate based on the current rate of change today. So this can be explained by the rate of change being higher in the most recent years than at the time of signing. There is, however, ongoing research to establish whether this acceleration is partly due to natural variability or if it is the warming itself that is accelerating. And I'd remind everyone of the hiatus years. So from a scientific perspective, we wouldn't want to preempt the trends in natural variability and draw asymptotes or draw correlations when we're really looking at the long-term trends, in addition to the year-by-year variability in the climate signal.
I thought that in your presentation, the graphic that allowed us to see from 2001 to today was particularly striking, actually, and I suppose that underlines your point. A question coming through from Manuel Planelis from El País. With the first one going to Florian, you get these ones. The political ones are coming in your direction, Florian. I'm sure you're delighted to get this one. I guess you're expecting it. Are you concerned about the steps that Donald Trump's administration is taking against climate science?
Well, it's a good question. Data and observations are obviously central to our efforts to confront climate change and air quality challenges. And these challenges don't know any borders. They don't know what language is spoken underneath them. And therefore, it's of course concerning that we have an issue in terms of data. However, in a recent interview by Neil Jacobs, the current administrator of NOAA, he has committed to that no data will be deleted, which is a welcome thing. At Copernicus, at ECMWF, and I'm sure also at the European Commission, we remain steadfast in the commitment to scientific integrity, to operational continuity, and to open data. And we will support that and ensure that the best data are available for everybody to make the decisions which they can do.
Thanks very much, Florian. Let's carry on with the second part of the question from Manuel Panelis from El País, who is asking Sam whether you can expand on the warming in the Arctic. What's going on there?
Yeah, so the Arctic is one of the fastest warming regions of our planet. Depending on which scientific paper you use, it's either 3 to 4 times faster than the global average rate. There is Arctic amplification, and there's also feedback from the rapid sea ice melting, which then changes the albedo. So the polar regions reflect a lot of the sun's energy due to the snow and ice cover there. And when that is lost and we have a dark ocean instead, the dark ocean absorbs that additional energy from the sun, which creates a feedback mechanism. So as I mentioned in my presentation, we didn't see a record low sea ice for either pole, but we did see a record low for both poles in February in 2025.
Thank you, Sam. Don't actually know who asked this question, but it's a question for Laurence. On the 5th of November, Copernicus stated the 1.5 degrees C benchmark is due to be breached by May 2029. Is there a view on when the remaining carbon budget for 1.5 will be exhausted, given the lag between gases being in the atmosphere and the warming happening? Laurence. Watch out for your microphone being muted.
Yes, sorry.
Tricky one.
Sorry. Yes. So yes, the colleagues from. So I was talking about the academic community, and released this information in November. We will be able to provide more information about the contribution. The contribution, I would say, of greenhouse gases emissions and concentrations in this result, in this impact in the coming weeks and months. We are already investigating with the data that we got from the academic community and from Earth observation community, because of course this is very important to rely on this. So today we can confirm the increase in greenhouse gases concentrations for 2025. We will give more details in the coming weeks. We can so imagine that there will be an impact on global temperature that will not go in the right direction, but this will give more information, especially in the report, the European report on climate in the coming weeks and months.
Thank you, Laurence. Question from Zia Weiss from Politico. First one I think is for Carlo. Can you explain a little how you've calculated that we've reached 1.5 degrees C of warming, and how close are we to 1.5?
Yes, C3S actually uses 3 complementary methods to estimate the current global warming level. There is not just a single silver bullet to get to that. You can do an average of the most recent 5 years. you can do a statistically smoothed time series up to the year in question, or you can use a linear trend over the most recent 30 years. By the end of 2025, all these three methods indicate a current global warming level of around 1.4 degrees above pre-industrial level. The third method, so the linear interpolation, is the one used in the C3S global temperature trend monitor, and also allows us to do an extrapolation. So assuming the trend that we have seen over the last 30 years continue, then we can extrapolate when the 1.5 would be reached in the terms of the Paris Agreement. And through that very simple methodology, you reach the conclusion that this limit could be reached by the end of this decade.
That seems very clear. Thanks, Carlo. Another kind of political question, quite similar to the one that we had before, Florian, about whether the Trump administration's climate science cuts actually affect ECMWF's data gathering, and do you expect that to have an impact in the years to come?
Well, ECMWF gathers global data from loads of different observing systems, which go far beyond just the US. So we also get data from other parts of the world, which I think is important to note in terms of backup. I already mentioned before that there was a commitment that the existing data will be accessible and not being deleted, which I think is important. Of course, what's important is future observations, because I can't time travel back to make an observation which I haven't made in the past. And that's, of course, quite important in that sense. And at the moment, I think it's too early to say how impactful a certain observation, which will not be measured or is not measured, will have on a future system. Data are key. Data don't lie. All we need to do is to measure them. They form the basis for this type of decision making.
Yeah, powerful message there. Thank you, Florian. Let's go over to Mauro. Your turn with a question from Torsten Cleaning from Spacewatch Global. Regarding the new satellites, what will be the value of the new satellites and what data are missing right now? What will be the actions that will emerge from those data?
Yes, thank you for the question. I don't know if the value meaning how much they cost, but I mean, I think that mostly the question is what we'll get from that. So first of all, we will continue with the current ones. Already, I would say that with Sentinel-4 and 5, they are very new, despite the fact that they have been launched in the past. Now they are really starting to generate new products, but they will be really fully operational beginning of next year. So already from those that have been already launched, there will be plenty of new products that will give data for air composition. For the future, beyond the current Sentinels, we have what we call expansion missions. There are 6 families of satellites, and they will add a few data. Mostly, we mentioned a lot the CO2M. CO2M is really looking into anthropogenic emissions, and for sure it will help us to better identify the CO2 emission in the air, but also to look into mitigation and adaptation solutions. But beyond that, there will be a satellite looking on land surface temperature, so that would also be helpful in identify some elements related to temperature. There will be hyperspectral imaging, so looking at very specific frequencies that can be seen on the land. And then there will be 3 satellites, meaning a radar L-band satellite, imaging microwave, and the polar ice snow topography. These 3 will give data that will be very relevant to the Arctic. So really to see the ice caps, the thickness of them, and to see the evolution of the Arctic. So I would say that in one way or the other, all the future satellites will be relevant to us, to C3S.
Thanks very much, Mauro. Let's pass on to a question from Eric Naylor from the New York Times. I think this might be for Sam. In addition to rising greenhouse gases, what are some of the other factors leading to the rise in temperatures in 2025? He's mentioning aerosols, ENSO, etc. Sam.
Yeah, thanks, Eric. So when we look at 2025, one important point that hopefully people got from the presentation was we're really looking at the last 3 years together and the exceptional conditions that we've seen throughout 2023, 2024, and 2025 versus all the years before then. And hopefully that was very clear in the time series and the maps that we saw in the presentation. The last 3 years have been exceptionally warm because of two main factors. The first one is the acceleration of human-induced climate warming. This is both greenhouse gases, but also reduced cooling from aerosols, including lower aerosol emissions from East Asia since 2010. And also the exceptionally high sea surface temperatures across the ocean. In part, it was due to the ENSO variability, so due to the El Nino event that we saw at the end of 2023 and 2024. But even in the most recent year, when we haven't been in an El Nino, we've still seen the exceptional sea surface temperatures, which are higher than has been recorded previously. Other factors, in addition to the two that I've mentioned, include changes in atmospheric circulation, so changing how clouds form and where they form, air-sea interactions and upper ocean mixing. There's also lower sulfide dioxide emissions from shipping. So many of you will have heard about the IMO 2020 rule, which reduces the sulfur in ship fuels. So that has reduced low-level cloud in the atmosphere, which means we're getting more solar radiation hitting the ocean and hitting the surface of our planet and warming up due to that increased radiation and reduction in aerosols. We're also at a solar cycle maximum, so that's an 11-year cycle. We're at the peak of that cycle at the moment. So there's a tiny amount of additional energy coming from the sun. And there's temperature and water vapor feedbacks. So the analysis has been done for the Tongan volcano in 2022, the Hunga Tonga volcano that emitted a huge amount of water vapor into the upper atmosphere. And the scientific assessment from that is that that has had a negligible contribution to global warming for the last 3 years. It is considered to be the same background level as natural variability, so similar to an individual El Nino event, which is at approximately 1/10 of a degree of warming. So there's a number of factors, but by far and away, the last 3 years have been due to the record amount of greenhouse gas concentrations in the atmosphere and record high sea surface temperatures.
Really interesting. Thanks, Sam. A question now for Carlo from Enza Tedesco at Montel News. Based on Copernicus data showing a trend of record heat years, how may rising temperatures affect power and cooling demand patterns across Europe? Do you foresee any impact on European energy supply or grid stability due to extreme heat, drought, wildfire events expected in 2026? Should this pattern carry on?
Yeah, electricity demand is highly sensitive to environmental conditions, especially the non-industrial electricity demand, and especially for some countries where electrification also of heating, like France, is particularly important. And we do know that a shift in the climate means that the historical peak in electricity demand in winter for heating is now associated also with the secondary peak that in some countries becoming quite dominant in Southern Europe for a summer peak for cooling. So that's a very important consideration for the demand profile, but also for the stability of the network. So we are working, for instance, hand in hand with the European Network for Transmission System Operator on how they can readapt that network to future challenge. And it is one of the reasons the European State of the Climate report that we publish regularly jointly with the World Meteorological Organization in April include information about electricity generation and the influence of climate condition of the year on potential renewable power generation. C3S in general provides climate indices specifically for the energy sector to support the sector itself and to support research and questions such as those Ensa was asking.
Thank you, Carlo. This one is for Sam from Hwang Duk Hyun, sorry for the pronunciation, from News One, the Korean news agency. I'm curious about the transfer of influence between regions. Could it be said that the effects of specific phenomena such as droughts, snow melting and heat waves in certain areas are intensifying due to the intensification of climate change? Korean readers are overlooking this part. I guess they mean that they're paying close attention to it. So go ahead, Sam.
Yeah, I'm not quite clear what the journalist means by the transfer of influence between regions. So there are teleconnections. So when we talk about natural variability, ENSO in particular, it starts off in the equatorial Pacific, and it does dominate the climate conditions on both sides of the Pacific. So, for example, in Peru and Ecuador, they've known about the El Niño Southern Oscillation for hundreds of years because their fisheries are heavily impacted by whether ENSO is in this warm phase or cool phase. It also impacts the probability of flooding in eastern Australia. So we know that there are local connections with natural variability, but then there's also teleconnections beyond that. But the further afield you get, the weaker those teleconnections are. So you can, and some people do argue that there is a footprint or an influence of ENSO in Europe, but the scientific evidence is often slightly contradictory, where some people will draw correlations and other studies don't see those correlations. So I think what we can say with certainty is that climate change is impacting everywhere around the world. And because of those impacts, there's no country or city that remains untouched by climate change. And then it depends on your local climatology as to how that climate signal will impact you. So in many parts of the world, we know that the atmosphere is warmer and that holds more moisture. So when it rains more intensely. So we are more susceptible to flooding now than we have been historically. That's in part due to heavier rain falling. It's also in part due to our increasingly urbanized environment. When we live in cities, there's nowhere for that water to go. Similarly, with heat waves, we know in a warmer world, heat waves become more intense, they become more frequent, and they impact more people. So these types of extreme events, the risk of them is increasing, and climate change is effectively a threat multiplier, where an individual event may not be directly attributed to climate change, because we've always had flooding events, we've always had heat waves, but they are often made worse because of that long-term climate change signal. Hopefully that's an answer to this question.
Thanks very much, Sam. I think this is another one for you, but maybe Carlo will want to jump in from Seth Borenstein from the Associated Press, given that you are also forecasting an El Nino later this year and perhaps a strong one. Are you expecting both in short term and long term changes in the rate and acceleration of warming? In other words, is the dramatic change itself accelerating, or does this look like a one-time step jump on a more continuous upward trend? And why is 3 years of 1.5 degrees important when the Paris Agreement was talking more long term?
Carlo, did you want to start?
Sure. Well, maybe just to say that it's very early in the season to say something definite about the possible El Nino by the end of the year. We do know there is a spring predictability barrier that blinds us to some extent on what's going to happen after the summer. So it's not, I wouldn't hold my breath. Nevertheless, it's a plausible scenario, and working by scenarios, I think, is something we need to become more used to. Having another El Nino is a matter of when, it's not a matter of if. So it might be later in this year, it might be next year or in 2 years, but we will have another El Nino, and this will bring a new peak in the global mean temperature. Now, for 2026, I think it's just a plausible scenario rather than something that will materialize for sure. So that's for typically for the seasonal prediction, and the best tool we have is to keep looking at this multi-system seasonal prediction that we, thanks to Copernicus, we have available for everyone to look, because while it's not certain, it provides us a useful scenario to work with. And maybe I can pass it to you for the second part, Sam, on the 1.5.
Yeah, thanks, Carlo. And it's really challenging to articulate and to forecast into the future whether the rate of warming has been higher in the last 3 years, or if and whether it's a new phase that we've entered into and it's a permanent acceleration, or if it's just part of the natural variability within that long-term warming trend. The other part of the question from Seth is that, we've had 3 years above 1.5 degrees, and what does this mean? So we know that the Paris Agreement speaks to the long-term warming above 1.5 degrees. So in and of itself, 3 years above 1.5 doesn't mean the Paris Agreement has been broken. It doesn't mean that we are likely to see 1.5 again and again in the future, looking at those temperatures alone. But when we look at the rate of carbon dioxide in the atmosphere, when we look at the continued rate of emissions from countries around the world, the reality is, unfortunately, that the last 3 years that we've experienced, when we look back in 5 years' time, they will be cooler than average rather than continue to be exceptional. This is why the Paris Agreement and international action is to get to net zero as quickly as possible, to reduce emissions, to reduce the global warming. We know that there is significant ecosystem disruption above 1.5 degrees, as well as intensification and increased frequency of extreme events, as I've already mentioned.
Thank you, Sam. We now have a question for Mauro from a freelance Greek journalist, Yannis Mouratidis, who's asking, why does the European Union remain loyal to the Green Deal, given that it appears to have failed?
Yes, I have to say that, we are optimistic in the sense we have to remain not just loyal to the Green Deal, you have to remain loyal to our planet. So this is the reason why we have to continue to look into that, even in a period when we see that in some other parts of the world, they are disengaging from that. And as a tangible demonstration for that, even the next MFF, there are objectives that 35% of the budget should be used for climate and environment. So in an horizontal way across the whole MFF. And again, the climate neutrality of 2050 still remains an objective. So we are still loyal, yes, to our planet.
Thank you very much, Mauro. A question from Kiyoshi Ando of Nikkei Japan. The Trump administration decided to quit the IPCC. Will this decision make it difficult for scientists to make AR7 report and to gather reliable data and information? Do you worry that the CMIP database will no longer be managed by US national institutions? Could ECMWF take the place of US institutions to manage the CMIP database? A question, I think, for Florian and Carlo there. Who wants to start?
Well, maybe I'll give a first step and then I pass it to Florian. Clearly, I'm not going to comment on specific decision of the US administration, but it's clear that bodies such as the IPCC benefit from all scientists all over the globe who want to work and who are working on climate. So limitation to the support and to the access of scientists to that report will inevitably be an obstacle in the development of new science. What we do as a C3S program is to work very closely with the IPCC. We have done that for the Atlas. The last report contained an interactive climate atlas that to me was one of the most usable elements of the report. And we picked up that atlas and kept up to date because of the IPCC process, the atlas needs to be frozen in time at the moment of publication. And thanks to C3S and to the Copernicus funding coming from the European Commission, we were able to keep that up and live. This is the kind of interaction we can have, and clearly we are at disposal of the global scientific community to keep supporting this initiative, including the support through the data.
Florian, do you want to come in with your thoughts? Not particularly. Okie dokie. All right, let's move on to the next question from Julius Sicker from Der Standard in Austria. Which development of El Nino is expected for this year and the upcoming years? Brackets, I read that it might be a shorter La Nina phase than usual. Is the yearly average temperature likely to go down after 2024's extreme, or rather go up? And that one, I think, is for Sam.
Yeah, thanks for the question. So Carlo already answered a lot of this. The moment we're in what's known the spring predictability barrier. So at this time in the year, it's really challenging to accurately forecast with seasonal predictions what ENSO phase we are likely to have. So if we look at the ENSO forecast right now, it looks like it's a forecast towards a warmer phase or an El Nino phase, but we need to look at the February and March forecast to have any reliability of what will happen after spring. As Carlo mentioned, for sure, we will have future El Ninos, and the El Nino adds about 0.1 degree of warming to the background warming for that particular event. So the second part of the question is whether 2026 is likely to be more exceptional than 2024. It's too early to tell. For sure, it will be in the part of the 11 warmest years that we've had already. And I think we're probably in this space that each year that we're announcing the review of the year before, we are likely to continue to increase that number. So last year it was the 10 warmest years have been the 10 most recent ones. This year we're 11. My expectation is that next year we will be saying 12 out of 12. But it really does depend on what happens in the natural variability over the coming few months to understand where 2026 will go.
Thank you very much, Sam. We've got more questions for you as well. This one from Kate Abnett from Reuters. Two questions for you, actually. First one is, you say the Paris Agreement 1.5 degrees C goal could be breached. Sorry, my computer is messing around. Could be breached this decade, and that this would be over a decade earlier than had been predicted when the agreement was signed. Please, can you explain why the predicted breach is now so much sooner? Have temperatures increased faster than scientists predicted, and if so, why?
Yeah, so really simple answer to this one, and that is emissions haven't come down as fast as people believed they would. So it's not so much that we've warmed faster, but with the Kyoto Protocol prior to the Paris Agreement, the expectation was that emissions would be reduced more rapidly than what we've observed over the last decade. So that's really the big differential between where we thought the world would look back in 2015 versus where it looks now at the beginning of 2026.
And the second one from Kate Abnett of Reuters, to confirm, is the 3-year period in which average temperatures exceeded 1.5 degrees C the longest period on record in which that's happened?
Yes, that's right. And I think it's important to point out that so our data goes live on Thursday. There'll be other international data centers that release their data as well. Not all of those international data sets will have the last 3-year average at 1.5 degrees. In the analysis that we've done, for us, ERA 5 is at 1.52 degrees. For that 3-year period. When we compare with the other global reanalysis, JMA 3Q, that's the Japanese reanalysis, they're at 1.5 degrees for the last 3-year period. So our expectation is that some of the others will be just below 1.5 degrees. And this is due to the long record and variations within each different data set over that long period. We're all very consistent in the near term because our planet is better observed than it has ever been. But when we look at these long-term records, there is variation between these different data sets.
Another question for you, Sam. Maybe Carlo will jump in as well. From Research Vedis from the German news agency DPA. Could you clarify the difference between the analysis that the period 2023-2025 has been the first 3-year period that's exceeded the 1.5 degrees C limit, even though 2025 was only 1.47 above pre-industrial level, and the outlook that this limit will officially be breached at the end of the decade if the current warming rate continues? And then secondly, could you explain why it's not surprising that the temperature records don't develop as a linear trend, meaning why does it not contradict global warming that 2025 was not warmer than 2024 and 2023?
Sure. So the first part of the question is very easy, and it's simple maths. So the anomaly for 2025 was 1.47 degrees. The anomaly for 2024 was 1.6 degrees. The anomaly for 2023 was 1.48 degrees. If you add those together and divide by 3, you end up with 1.52 degrees over that 3-year period. The reason why the 2025 doesn't have to be warmer than 2024, despite the long-term trend, is really why so many people are fascinated by the weather. Our weather is incredibly dynamic, and even though we've got this long-term warming, what happens around the world is utterly dependent on the weather systems that we experience. So one of the really interesting contrasts between 24 and 25, particularly in Europe, 24 was a very dim year. So even though it was the record warmest year, in Europe we had a lot of storms. We had the highest water vapor in our atmosphere ever recorded. And we had a huge number of named storms that impacted Europe, and we saw a lot of flooding in 2024. In 2025, it was a much sunnier year. We had heat waves early on and throughout the summer. So that's part of those weather systems that bring in what we experience. And it's really averaging what we experience at a local level, day by day, month by month, to get that annual anomaly of what the world has experienced. And we can see overwhelmingly that, for example, the UK had its warmest year for 2025, but many European countries didn't, because we can see that across Europe, it was warmer for the year in the west of Europe and cooler in the central and eastern parts. So that's just part of the natural variability.
Thank you very much, Sam. Very, very interesting. Gave me an opportunity to test out my primary school level maths as well. And I'm fully in agreement with you on it. We had a question from Alec Lunn from The New Scientist here. He said, you mentioned Antarctica had its warmest year on record. Has Antarctica entered a new regime in terms of temperature or sea ice?
A really interesting question and challenging to answer. So when we look at the long-term records for sea ice in Antarctica, it seems to be that about the last 10 years, so since about 2016, we've seen a decline in Antarctic sea ice. Again, I and many other climate scientists really loathe to draw an extrapolation of a short-term trend. But it does look like over the last 3 years, we've had a series of record low Antarctic sea ice. Whether that continues will ultimately very much depend on Antarctic variability, which is higher than other parts of the world. It also depends on ocean temperatures. So we know that the ocean everywhere is warming up, particularly the Southern Ocean. And there are also scientific reports that show that the Antarctic circumpolar current is slowing down due to that freshening from increased ice melt in Antarctica. So there's a lot of different climate factors going on here, but it does show this high level of variability within the Antarctic region.
Thank you, Sam. A question for Carlo from Craig Eason at Tradewinds, which is a shipping news publication. Can you give any indication on rising temperatures and extreme ocean weather? Does the climate data you have include extreme weather? And if so, are there any trends?
Well, in this report, we do cover notable extremes across the globe in 2025, but we have not been investigating trend in extremes in details. This is done with a bit more depth in the European State of the Climate report I was mentioning before, that will be published in April. At the same time, C3S has started an activity on extreme event attribution. This is mostly happening behind the scene, but it will become, or some element of it will become visible in the next few weeks, and this will provide more information, especially at least to start with, on heat waves and temperature extremes.
Another question that's come in for both of you, actually, Carlo and Sam, from Audrey Garrick at Le Monde. She says, can the entire temperature increase reached in 2025 be explained, or do you still wonder about the possibility of self-perpetuating vicious circles in the climate? And what do you expect from the climate, or what climate do you expect in 2026?
Maybe I'll start some and then I'll pass it to you. Well, maybe let's start from the second one, what to expect in 26, because this is partly what we covered before to the previous question. So it's always, it goes partly back to the question that was asked before about the non-linearity in temperature, in the sense that there is an underpinning warming of the climate system, which means that higher or new records are more likely to occur than otherwise. But overimposed to that trend, which is not necessarily linear, by the way, there are these oscillations such as El Niño and La Niña, solar cycle, and so on and so forth. So in 2026, at the moment, there is a chance that we may enter a new El Niño phase. It's still to be seen, but even without El Niño, chances are we are likely to see higher than usual temperature. On the wondering about the possibility of self-perpetuating vicious circle, I think we wonder. I don't think we necessarily have an answer about it, but Sam, maybe you want to elaborate more on this point.
Yeah, sure. So I think when we look at a warmer world, we know that extreme events become more frequent and more intense. We also know, as I mentioned already, that when we have severe storms or flooding events, the rain is more intense. So there is more awareness of the extreme events that happen, and those extreme events are made more probable in a warmer world. We're also seeing new classes of events coming in. So many of you will have heard the 1 in 10 year or 1 in 100 year scenario of particular events. Now we're seeing 1 in 100 year events that happen, perhaps every 5 or 10 years, or perhaps they will get towards that direction in a slightly warmer world. What we can say, as Carlo mentioned, comparing 2025 and 2026, in some ways, there's a lot of analogies. Almost this time last year, we had record wildfires in California. Right now, we have record wildfires in Australia due to heat waves and due to drought conditions. So we can't blame climate for either of those individual events, but the background climate change makes those events much more probable and a much higher risk of them occurring.
What are your expectations for 2026 then, Sam?
I think as Carlo mentioned, it does depend on whether we go into this warmer phase of ENSO, so El Niño event. My expectation looking at sea surface temperatures, well, I guess there's a difference between expectation and optimism. So my optimism is that sea surface temperatures would continue to decline. So we have seen an erosion of sea surface temperatures compared with that peak at the end of 23, early 2024. That's good news for the ocean. Is good news so when the ocean is warmer, we get more evapotranspiration, we get more energy entering the atmosphere. So that's good news for weather dynamics, it's good news for ecosystems. So my expectation for 2026 is that it will be one of the top 5 warmest years. Maybe it will be comparable to 2025, but it really remains to be seen what happens with natural variability over the coming months. I think from an aerosol perspective, we're unlikely to see many changes unless we have a volcanic eruption in the right place for stratospheric cooling to happen. And we're unlikely to see any changes in solar activity as well. So it's really those aerosols and ocean temperature that will influence what we see in 2026.
We have another question from Ruth Douglas at the Belga news agency. She says, Copernicus stated in November that the 1.5 average threshold would be breached by May 2029. Today's statement says it will be breached by the end of the decade. Why are those forecasts different? And what would be the impact on people's lives of breaching 1.5 degrees?
Sorry, no.
Go for it.
Well, for me, May 29 is pretty close to the end of the decade. So the two statements are not in contradiction. I mean, if you look in terms of decade, 6 months are within the noise. So basically, we are saying the same thing.
And maybe I can add to that. Again, it was me being optimistic that perhaps between now and the end of the decade, we will see a difference in emission reductions that will change how optimistic we can be with when the 1.5 will be exceeded in the long term.
The last part of that question is super interesting. Now, what would be the impact on people's lives of breaching 1.5 degrees? Maybe you could develop a little bit on that.
Yeah, so 1.5 is one of those really funny things when, you know, where most of us live, we experience 20 or 30 degrees of temperature change across the year within seasonality. So for many people, there's this foreign expectation of, you know, an extra 1 or 2 degrees. That's great. I can have more barbecues in summer. You know, I can wear my summer wardrobe, you know, more days of the year than perhaps in the UK, where it's, you know, it normally comes out for only 2 or 3 weeks. But because this is a global average, the reality is that when we have a 1.5 degree of warming at a global level, that means that heat waves are often 3 or 4 or even up to 10 degrees warmer than they otherwise would have been. The 10 degrees warmer is at the poles, so it's only at the moment locations like Greenland and Antarctica where we see those exceptional high variability, where we're seeing heat extremes going beyond what has been recorded historically. But we've seen 40 degrees in London 2 years ago or 3 years ago now. And that 40 degree in London would not have happened without climate change. So it makes extreme events worse. And it's those events where they impact society, they impact people's health, and they impact ecosystems. So we'll start to see those disconnect and the challenges with our infrastructure coping with the climate that we're facing now. And I think this is a really important point, that the summers that we're facing now are very different to the summers that our parents experienced, very different to the summers that our grandparents experienced. So, you know, there is a generational divide when we're looking at climate change, and future generations, so children today, will be exposed to more heat hazards and more climate hazards than perhaps we were or our parents were. So this brings in the climate justice and the climate equity of having that change and that political ambition to reduce emissions, because it is not only impacting us, it's impacting future generations that have to live with the consequences of decisions that we're making now.
Thanks, Sam. Another question to you, again from the same news agency, from the Belga news agency, from Bo Bouillard. Sorry for the pronunciation. Not an easy one to pronounce, that one. But thank you both for the question. How would you explain the higher temperatures in the polar regions, especially in the Antarctic?
Yeah, thanks for this question, because I forgot to mention it in the New Scientist answer. So sorry, Alec. There was also one of the key features for Antarctica for 2025 was that there was a stratospheric warming event. So the record annual temperature for Antarctica in 2025 came from much higher than average temperatures during the austral spring, which is the September to November period. And these were largely related to a sudden stratospheric warming event that happened in September. This type of event is quite rare over Antarctica. It causes a rapid spike in temperatures high in the stratosphere, so in the upper atmosphere at 10 to 50 kilometers above the surface of the Earth. And this caused disruption of the strong cold polar vortex and led to much warmer than average temperatures at the surface.
Pretty crazy what's going on in Antarctica, isn't it? It's just extraordinary. I'm just waiting for the next question to come through. Actually, I don't have any visibility on them. I know that they're there in a second. Here we go. One from Stefan Sadlacek at Respect, the Czech Weekly. How many people approximately died last year in Europe due to the effects of climate change, extreme weather events like heat waves and floods enhanced by climate change? Secondly, do you feel the impact of the new US administration's actions against climate science in your work, which we've covered to an extent already? And thirdly, do you have any updates on AMOC, including Gulf Stream and climate change influence and possible impacts? There's a lot there. Who wants to have a go? Sam?
I certainly can start. So this is the number of fatalities isn't something that C3S records directly. And there's no estimate available for 2025, but an update will be likely to be provided in the European State of the Climate, which will be released later this year in April. In 2024, it was estimated that over 300 lives were lost in Europe due to storms and flooding, and that there were over 62,000 heat-related deaths. So towards the spring, there will be scientific publications that come out. They're often incredibly high profile. So keep an eye out for high profile journals to give those updated estimates of the heat-related mortality due to the heat waves from 2025. And I'll hand over to Carlo for the second part of the question on the Gulf Stream.
Thank you, Sam. Yes, the second part of the question is, I think, two questions. One on the US administration, and I guess, as Jeremy was signaling, I feel we pretty much answered that question to the level we can answer. The last one is about the AMOC shutdown. The changes in the AMOC, the Atlantic Meridional Overturning Circulation, is not something we have investigated in this report. And what there are some studies, especially over the last couple of years, indicating a possible collapse of the Gulf Stream being more likely than previously expected. There is no strong consensus across the community on how close we are to that tipping point. And actually, there is no full consensus on whether the AMOC has slowed down to a significant level in the observation itself. Naturally, considering the far-reaching consequences of a possible AMOC shutdown, especially for Northwestern Europe, it makes sense to look at those and keep monitoring the state of the AMOC.
Thanks very much, Carlo. And I think the last question goes to you as well. And this is from Eric Roston from Bloomberg News, who is asking, what climate science questions do you most wish you had answers to?
Yeah, I saw the question, and actually I was trying to make some space in my mind to answer, because it's such a good question, and I feel that I will never be able to find a really good answer for it. The simplest one that comes to mind is, what is the climate sensitivity of the planet? The real one, not the model one. That's the response in temperature to a doubling in CO2. These have been moving around to some extent, has not changed radically from the back of the envelope calculation of scientists at the end of the 19th century, which tells a lot about the power of the science. And still we don't know for sure. So in the absence of a more profound answer, probably this is the one I would look at.
I always think that you scientists must have pretty big envelopes, because I don't think I could do all of those calculations on the back of an envelope. I don't know how big they are. You guys just send very big letters. Thank you very much. It's been a fascinating conversation, really a great pleasure. Thanks for everybody for sending through your questions. If you sent us questions which we were not able to answer yet, then we will get back to you. The Copernicus Media team will reply, and please contact the Copernicus Media team should you wish to organize any one-to-one interviews with any of the people here, or if you have any other follow-up questions as well. And you can reach out to the same people if you need help with data, clarification on a particular point of climate or atmospheric science, or issues on how to present the graphs, maps and charts. And Maximilian has been giving you links and passwords on the side here as well in the chat, so you can download all of the information. As I said at the beginning, please respect the embargo, which lifts on the 14th of January 2026 at 4 a.m. Central European Time. And the email address for the press team is copernicus-press@ecmwf.int. Thanks very much for being with us. Please take a minute one you check out of this to fill out our survey. Let us know your feedback on this session, and we'll see you again soon. Thank you for watching.